Good morning, students. In this session, we are doing some more problems from Cauchy's sequence and Cauchy's general principle of convergence. Then we will just revise what is Cauchy's sequence that we discussed in previous video. Then a sequence In is said to be a Cauchy sequence if for every epsilon greater than 0, there exists a positive integer m such that modulus of an plus p minus an less than epsilon for every n greater than or equal to m, p greater than or equal to 1. That we have already discussed in previous video. Now we will do some more problems based on this Cauchy sequence. Prove by definition of the sequence an whose nth term is given is a Cauchy sequence. Here sequence an is given as sequence 1 by n. That is an is 1 by n. Then let epsilon greater than 0 be given, let n greater than m. Then modulus of an minus m, modulus of an minus m equal to what we get? Modulus of 1 by n minus 1 by m. Again, here what we have taken n greater than m. Just listen here. Here I have written n greater than m. N greater than m means 1 by n what we get? Less than 1 by m. Then which one? 1 by m minus 1 by n will be greater than 0. Then modulus of 1 by n minus 1 by m, that we can write it as minus of 1 by m minus 1 by n, because 1 by m minus 1 by n is positive. Then when we take modulus sign, modulus of minus of 1 by m minus 1 by n, it will become 1 by m minus 1 by n. Then it is less than 1 by m because 1 by m minus some more negative number, 1 by m minus some positive number means that should be clearly less than 1 by m. Then it is less than epsilon. Then for each epsilon greater than 0, there exists a positive integer m such that modulus of an minus am less than epsilon for every n greater than m. Then sequence an is a Cauchy sequence. Next one, prove by definition the sequence an whose nth term is given is a Cauchy sequence, where an is given as n by n plus 1. Consider an equal to n by n plus 1. Let epsilon greater than 0 be given. Let n greater than m. Then modulus of an minus am equal to modulus of n by n plus 1 minus m by m plus 1 equal to modulus of, we are adding and subtracting 1. That means 1 minus n by n plus 1 minus 1 minus m by m plus 1. That means when you simplify that, what you get? N plus 1 minus n is 1 by n plus 1. Here, then here what you get? M plus 1 by m plus 1 is 1 by m plus 1. Simplify that. Then taken minus side outside, then 1 by m plus 1 minus of 1 by n plus 1 equal to 1 by m plus 1 minus 1 by n plus 1. Here what we are, that like previous problem only, since n greater than m, what we can write? N plus 1 greater than m plus 1, or 1 by n plus 1 less than 1 by m plus 1. That means 1 by m plus 1 minus 1 by n plus 1 greater than 0. For that only, actually here we are, when we are simplifying, we are getting 1 by n plus 1 minus 1 by m plus 1. But we take minus sign outside, then it will become minus of 1 by m plus 1 minus 1 by n plus 1. Then modulus sign means it will become 1 by m plus 1 minus 1 by n plus 1. Then 1 by n plus 1 less than 1 by m plus 1. It is less than 1 by m, less than epsilon whenever m greater than 1 by epsilon. Then for each epsilon greater than 0, we got that there exists a positive integer m such that modulus of an minus am less than epsilon for every n greater than m. Therefore, sequence an is a Cauchy sequence. Now last problem, show that sequence n is not a Cauchy sequence. We consider modulus of an minus am where n equal to 2p plus 1, m is 2p. So that n and m are greater than p. Then what we get modulus of an minus am? N minus m, because an is given as n, then am will become m, modulus of n minus m, but n we consider 2p plus 1, m is 2p, that means 1. Modulus of n minus am is 1. Then if we can find out at least 1 epsilon that doesn't satisfy mod n minus am less than epsilon, means it won't become a Cauchy sequence. Then here modulus of n minus am we are getting as 1. Then we take epsilon equal to 1 by 2. Then we want to find out positive integer m such that mod n minus am less than epsilon. Therefore, sequence an is not a Cauchy sequence. Thank you so much.